Hello guys, here we go again. Today, very briefly, I will be talking about the theory, a little bit about the theory. So, we're talking about the strong cohesion, loosely coupling, decoupling, reuse. All these principles, rather concepts, are very good because strong cohesion means that each one of the elements of the software should do only one thing. Responsibilities should be each element should have only one responsibility. Loosely coupling, that means that the elements of the software shouldn't depend on each other. Each element should be able to be taken from the software and put in another software project, and it should work. And this leads us to the reuse. So on this quest to achieve strong cohesion, loosely coupling, decoupling, reuse, we came across a concept which is called inversion of control. Before we dig in this concept, also I have to mention the cost of change. We're talking about the cost of change as well. If the architecture of our application is such which allows us to decouple the elements and reuse them, the cost of change will be very low. Initially, the cost of change, if we do hacking, is low, but that's until our code reaches a certain number of lines. After that, the cost of change reduces, or actually is less, if we have a good architecture, loosely coupling, strong cohesion, if we follow these principles. So, as I said, we came across another concept which is called inversion of control. Martin Fowler is a specialist in this area, and if you want, you can go to the mind map which you see in front of you right now, find the links to his blog and read about the inversion of control. Also, Ralph Schindler, has a webinar where he discusses the inversion of control in connection with Zend Framework 2. It's also a very good webinar, and there are many more sources. So I will give you my interpretation of the inversion of control. The best is just to explain it by one example. So now let's consider this. We have a class A and we have a class B which consumes class A. As you can see here in the constructor, we are sending as a parameter class A into the constructor of class B. So B becomes dependent on class A. But when we talk about the inversion of control containers, which are very fashionable right now in the world of programming, I have to attract your attention on something else. Notice this: in class B, when we instantiate class B, we don't use the constructor of class B to instantiate class A, but in opposite, we just inject an object of class A. This is the main difference. This is the inversion of control, actually. I'm sorry about the fact that the indents are not properly here, but hopefully you understand that. So this is a public function constructor, and as you can see here, we sent as parameter the object of class A. We don't construct, we don't instantiate class object of class A here in the constructor. We just inject it. This is the inversion of control. So the consumer of B actually will determine what kind of an object is gonna send to the constructor. Okay. This is the inversion of control explained my way. Also, I have to give you another example. This is the classical example used in the Martin Fowler article about the inversion of control and the dependency injection design pattern and the service locator design pattern. So the assumption is that we have a software which does something like this. We display a list of our movies. This is a very simple example. The problem here is that we want to send this class, which is called lister, to our friends and give them the opportunity to list their movies, but their movies could be stored in a different data source. For example, somebody could use a comma separated file, another guy could use a database whatsoever. So the finder, which actually finds the movie we're searching for, let's say we're searching for movie by name of the author of the movie, this finder should work with all these data sources. How to do that? We have to give a chance to our friends to use different finders, to override our class finder and use their own to meet their own needs. Okay, how can we achieve that? By sending the finder, like in the first example, as a parameter where we construct the lister. So all we have to do is just send a different finder. We just to inject a different finder. Here in this example, what do we see? The lister has dependency on the finder. That's the first thing. The way we fulfill this dependency is by sending the finder to the constructor of the lister. So how we are sending the finder? We're doing that by sending one instance of the finder. The lister is not going to instantiate its own finder. It will be provided with a finder to consume. This is composition, one example of the composition, but is an example of something else as well. It is practicing the inversion of control. The consumer is expected to inject the finder to the lister. So finally, the guy who uses the lister is responsible to inject the finder into the lister. Okay, this is what we learned from this example. Let's see what else do I have to say. As I said, it's gonna be very quick. I'm not gonna get into the details. If you want to read more about this, go to the Martin Fowler excellent article. I'm gonna show you this. I'm gonna show you the URL. You can read about the dependency injection as well, going to Zend, learning dependency injection. Hopefully the URL is seen. I will zoom it. Here we go. And also here it is, the Ralph Schindler excellent webinar about the inversion of control, dependency injection, and how this is implemented in Zend Framework 2. I'm talking about the inversion of control, dependency injection, because and also I'm gonna talk about the service locator, because they are used in Zend Framework 2. Actually, they're fundamental for Zend Framework 2. Of course, there is something else which I will talk about in the event manager, which is very, very important for me as well. Okay, in any case, let's concentrate right now on the DI, dependency injection, and let's mention the fact that this is a design pattern. So, to practice the inversion of control, we can use dependency injection pattern, but there is another pattern which we can use, and this is a service locator pattern. I just will go a little bit ahead of me and say that service locator is something like a repository. From the standpoint of view of the user, it looks like a repository. Service locator is an object which can instantiate and return objects. Okay, we will talk about that shortly. So, dependency injection, and let's look at this design pattern first. The implementation of the dependency injection is the dependency injection container. Dependency injection container is a tool which we use to practice the dependency injection pattern. So we already saw the dependency injection constructor injection. There are two more ways. to implement the dependency injection design pattern. Setter injection, that's done through setters. And since I don't think I have one example, I'll write it in front of you. So let me do that. Let's say we have class B, it's not done. Notice this is the difference. Now we have a public function set A, it's a setter, and parameter. Okay, and I'll say class A. Just very briefly, very shortly. Okay. Sorry, I have to do it this way with spaces instead of tab, because the tab doesn't work, and also indents are lost after saving the node. So sorry about that. I'll figure out the way to do it properly. Okay. So this is what we have, and this is one example of the setter injection. It's in the branch setter injection. Here it is. Class A, class B, and the way we inject the object of class A into class B is through a setter. That's why it's called setter injection. And the third type of dependency injection is the interface injection. This is taken from Ralph Schindler webinar. So we have a namespace movie app. I told you about this this application. Martin Fowler is using it, of course, with Java. His examples are in Java. So we have a class lister implements finder aware interface. Okay, this is the main difference. So our class listener makes a contract with a finder aware interface to implement all its methods, and the method is setFinder, and it looks like a setter dependency injection. In this case, we just have to implement the setFinder, and here you go with the finder. So those are the three types of dependency injection. In this branch you can see the sources of information, links to different webinars and sources in the net where you can read about the inversion of control and dependency injections. So let's look at and discuss the pros and cons of all this type of dependency injection. Constructor injection, pros and cons. Let's see. Object in ready state. Immediately when we instantiate object of class B in our example or lister, we have it ready to work for us. Clear, easy and simple. All the injections are injected as parameters on the constructor, and they're giving to the class, to the object when we instantiate it. Object declares complexity up front, so we immediately can see how complex is the object which we are creating by looking the parameters, the injected objects which we have to send. Could be cyclical, which means that those are cons. Now I'm talking about the cons. Let's say we have class A and class B, and they both depend on each other. Which class to instantiate first and set it as a parameter to the constructor of another class? That's very interesting dilemma. Hard to change the properties of the consumed object. So once the objects have been consumed, it's hard to change their properties, because we instantiate first the dependencies and we inject them in the constructor. So we have only one opportunity to set the properties of the injected objects, of the dependencies. That's before creating the consumer. There is a param per dependency. If the object has too many dependencies, then the parameters we have to send during the instantiation become a very big list. If that's the case, then we have to think about our design, but it's cons right now. Not polymorphic. What that means? That means that if somebody wants to inherit my class B, the consumer, he has to be very mindful about the injection which needs to be done, and he either has to call my parent constructor or he has to take care of the injection. Okay, those are the pros and cons of the constructor injection. Let's look at the setter injection. Then through the setters. Clear injection point for each injection. That's a pro. Actually, we like that. I like it too. Martin Fowler, by the way, always features the constructor injections over the setter injection. Okay, so the cons. Consumer has to be very honest about all injections. So the consumer should call explicitly each one of the setter methods in order to get his object working. Let's call it again. Construction is not upfront. So we don't know how complex the object is. And on top of that, there is another disadvantage. Some of the injections may not be required for a given use case. But we don't know which are required, which are not required. So we may not call all of the setters, but we better do, because we don't know what's gonna happen and how we are gonna construct the object if we don't call all of the setters. Those are the pros and cons. Interface injection. It's a semi-pattern if in the name of the interface is used the word aware. That means that we are practicing right now interface injection. So if you see something like that, the word aware, in the interface definition, in the interface signature of a given interface, so keep in mind that could be an injection. We could be practicing interface injection. Cons. A lot of interfaces. As a pros, I could say that it's for very disciplined programmers. Everything is very well organized, and the code is explained itself. As I mentioned already, dependency injection container is a tool. It's an implementation of the design pattern. Okay, let's look at now the service locator. The service locator, from our standpoint of view, looks like an object which returns to us all the object we need into a given object. Itself, the service locator becomes a dependency, because we have to inject into each one of our objects a service locator in order to allow our object to instantiate, actually to get all the dependencies. So it's alternative for dependency injection pattern. I'm gonna use again Ralph Schindler, who is using these expressions. Service locator doesn't equals dependency injection container. It's not the same thing. But on another hand, dependency injection container equals service locator. What that means, it's a little bit confusing. Dependency injection container can be the foundation of consumed for service location. Okay, let's say we have to inject the service locator into an object. How we can do that? We could do that using a dependency injection container, or where we have already the service locator and the service locator is asked to return a certain object, how the service locator assembles the objects which it returns. It could be done through a dependency injection container. So that's why they're very close. It's a foundation for the service locator. Dependency injection container is a foundation for service locator. Cons. The bad thing is that the service locator becomes a dependency for the object, for the consumer. Pro. Not all code paths may use all dependencies. What that means? There are use cases when we don't need all the objects necessary for one object in order to assemble this object and make it usable. In different use cases we will need a different set of objects, and the service locator allows us to fulfill these use cases. For example, we can create less object and make our object which we are assembling right now and make it work for a given use case. We don't need everything. We don't need all the objects. Okay, this is very briefly about the service locator design pattern and dependency injection design pattern. Why I'm talking about them? Because the Zend framework, as I said, is using a lot of dependency injection container. So we have a Zend component called dependency injection. This is the Zend dependency injection implementation. It's not a recommend to use it. It's, as usual, use at will principle, follows the use at will principle of Zend, and supports both construction injection and the setter injection. And I have to mention that dependency injection design pattern and dependency injection container is not a very good idea to be used for hello world type of objects. When we assemble an object, and actually when we don't have to assemble an object, which is very simple and it doesn't depend on other objects, maybe it's not very good idea to use a dependency injection. But for very complex objects, dependency injection container is a good tool and should be used. Okay, that's for today. This is what I wanted to mention today, and see you next time where we'll continue talking about the Zend framework 2, a little bit about the theory, and we'll see what else we'll do. Okay, see you soon. Thank you very much for your attention.